So, yes, as the quadrants or coordinate plane, my green axis is the what? The X, my yellow axis is the Y. So as Lauren just asked, this is quadrant 1, and then we go left, 2, 3, 4. Most important part of that is we got to write them as what? Roman numerals, don't forget that. So 4 is what? IV, okay? Any questions like that? If it's on one of the axes like number 2, then you can just say that axis or you just say none for the quadrant. Okay with that? Distance formula, everybody know it? Need to write it down. D equals what? Square root. Don't forget that square root sign. Then what do we do with the x's? Minus x squared. Then in between, we add. So, does it matter which order I do my x's and my y's? Nope. Because why? Again, because we're squaring it. Doesn't matter if we get a positive 1 or a negative 1 inside there, we're squaring it, so we still get 1. But the very last thing is, don't forget to take the square root of it. Okay? You need to see actually one of those. Okay? Midpoint of any segment or through any given endpoints. What was the formula for a midpoint?
X1 plus X2 divided by 2.
Now we're going to take basically the average, right? And what's the most important part of this one? That it is a point. Your answer is a point. Okay? So I would really make sure that my subscripts are the same. And don't believe it really makes a difference. Yeah, it should make a difference too. So make sure they're in the right order, or the same order. Doesn't really matter which way, but that's the same. Okay with that one? On an acute angle, it's what? Less than 90 degrees. An obtuse angle is greater than 90, but less than 180, right? So all you got to do is actually physically draw those. Good with that? Yes. Converse, inverse, and contrapositive of the conditional. Again, remember this is where we did a lot of the writing. Conditional is just the sentence that they give us. So the first thing you have to answer is true or false to that. If two lines intersect and form 90 degrees angles, the lines are perpendicular. True, right? Then we go through and we're going to write the other sentences. What did the converse mean? You flip them, right? The hypothesis and the conclusion. What's the hypothesis? After what? If, right? The conclusion is after then. So I just flip-flop them. And then I answer the question again. So what would the converse be?
If the lines are perpendicular, then two lines intersect and form 90 degrees.
And what would you say? True, right? If it's false, we would then have to what? Make a what did we call that? No. Counter example. Right? We got to come up with the counter example. What's the inverse? Now say it. No, what you just said before. The other word.
I said contrapuntal.
Somebody else. You said it then. What? The inverse is to negate both parts. Okay? But you got to go back to the original one. So this one would be, if two lines do not intersect and form 90 degrees, then the lines are not perpendicular. And then what's the contrapositive? Both of them, right? Flip them and negate. So this one would be, if the lines do not or are not perpendicular, then the two lines do not intersect and form 90 degrees. When we're talking about the true and false part, if the first original conditional is true, what else has to be true? The last, right? The contrapositive, if you go in this particular order. Then the two middle ones have to be the same answer too, meaning true or false. And then don't forget that counter example. Good to go there? The next two sections are basically the same thing, and you're going to use that little figure over here. But this involved our vocabulary, right? We had alternate interior, alternate exterior, corresponding, consecutive interior. You could still use linear pairs. You could still use vertical angles. The last two don't necessarily involve a transversal. Okay? So, you need to talk about 9 through 14. Any of those? Everybody okay with all that vocabulary we just said? Again, you might have to name the transversal. Remember, the transversal is the part or the line that includes those four little pieces. Okay?
Wait, the corresponding is hard.
Corresponding means in the exact same spot. So, 1 and 8, 1 and 6, 1 and 15. Because they're top left-hand corner of the four pods, or the four things in a pod. Consecutive interior are 5 and 16. If my lines are parallel, 5 and 16 would do what? If they're consecutive interior, when the lines are parallel, they add up to 180, right? We don't want to say that they're a linear pair this time. We want to say they're supplementary, because they don't necessarily touch. Okay? Good with that? Formula for slope from any 2 points.
y2 minus y1 over x2 minus x1.
Difference of the y's over the difference of the x's, right? But she's right. We have to make sure that our subscripts are in the same spot. So I could have done the y or the ones first, but then I have to do both the ones first. Okay? Difference of the y's over the difference of the x's. If I have parallel slopes, what's true about them? They're the exact same. If they're perpendicular slopes, they're what? Opposite reciprocals, right? So, if we have m equals 3/4, the parallel slope is 3/4, the perpendicular slope is negative 4/3. So we flip it, that's the reciprocal part, and the opposite part just means we change the sign. So if it was negative, it becomes positive. Okay with that? You want to see like 15? The actual math on that one? 16 and 17, all three of my angles in a triangle would equal 180 degrees, right? You cannot do that. You cannot use 180 degrees if they're talking about the sides, only the angles. So 17 and 18, obviously 17 only has two quantities, but I know the third because of what? The box, right? Okay with 16 and 17? Number 16 I can do. So in number 16, I'm going to take all of my quantities and add them together. And I'm going to set it equal to 180 because I know all three of my angles have to equal 180. And then I just do the algebra. So 4 plus 3 is 7, 8, 9x. And then I'm going to subtract 5 to this side. And then I'm going to get x all by itself. What do we get? 1, 9 into 85 goes 9 times, so it looks like it's a decimal. 4 9ths. And then just make sure for every single problem that you do, make sure that you answer the question. Okay? This one says just find the value of x, so that would have been our answer. If it says find all of the angles, then I have to put that back in for each one. Okay? Questions with that one? Uh, 18. How can I find x?
Sorry,
Wait, 18. Add
18.
them, add them up and then take it from 180, so then you get 27, and then you can do 4x plus 3 equals 84.
Exactly right. Did everybody hear what she said? So we're gonna use exterior angles and remote interior angles. 4x plus 3 is equal to 84 plus that blank angle there. Or, I could have done what? I could have done linear pair too, right? Right down here in this little corner, I can do a linear pair, so I could say 69 plus 4x plus 3 equals 180. Could have done it that way too. Need to see the math? Okay. 19 and 20, we're just going through. What are the 4 ways that we can tell that triangles are congruent? Side, side, side. Side, angle, side. Angle, side, angle. And angle, angle, side. Remember, we can't ever have ASS. So, number 19, we would say what? Side, angle, side. And number 20? Kind of ran that one off the page. Remember now, if they go to the next step, now we couldn't really do it this next step with these two because they don't give us the vertices. But if they ask you for a congruent statement, that means we have to write them in the exact order. So that's where you kind of try to match up all of the little slashes and arcs. Okay? You start with one of your triangles, say ABC, and then you match that second one with it. Okay? Turn it over. Ooh, the old proof. That one looks like it's pretty easy though, right? Anytime, so in a proof, where are we starting? Always with the given. What's my reason why? The given, right? Don't miss something like that easy. Anytime that I have parallel in the given, what should we think about? Alternate interior angles, perfect. Again, if I have something like N right in the middle, I'm thinking about vertical angles. If they're a shared side, we would think about reflexive. If they talk about a bisector, we're seeing what it split it into. Same thing with the midpoint. So all of those are key words in the proof. Do you want to go through the proof? Yes. Okay. So, LM is parallel to OP. LN is congruent to NP. Here's my figure. Right? So again, this right here, LM is parallel to OP. LN is congruent to NP given. That's what we're going to start with every single time. Okay? So, the next thing that we have to look at is there anything in the given that we can just put on our chart or on our figure? And this right here we could just put on there, right? LN is congruent to NP. So don't forget to draw your figure. Well, you won't have to draw it because it will be given to you on the test. But don't forget to mark it up. Okay? Now what do? Again, what did you tell me if we're talking about parallel things? Alternate interior angles. So what angles are alternate interior angles? Remember, it has to touch the parallel side and the transversal. So which one would you want to say? Angle what? M is congruent to? Angle O. Perfect. Alternate. Interior or exterior? In. And then come back. Okay, what else? What? L and P. So we could do it as this, right? Angle L is congruent to angle P. Again, by the same thing. So both of those are alternate interior angles. And then I would come up here and write those down. And now I would have what? for my triangles? Do I have one of those four things? Angle, angle, side. And so this is where we were talking about. Triangle, now I gotta make sure that I put them in order. So what's this first triangle? I don't care how you say it. What would you say? MLN is congruent to triangle. So now what is in the same spot as M? O, L, P, and then N again, right? And are we done? No, we got one more step, right? And remember, I can't use this reason why until I prove them congruent. So now we're ready for the proof. LM is congruent to OP. Because why? Yeah. We're getting good at that one. Again, what's that mean? Corresponding parts of congruent triangles are congruent. So once I figure out that they are congruent triangles, all the pieces that are corresponding, meaning in the same spot, have to be congruent to each other. So again, I would probably look at that one quite closely. It might look the same or similar to the one on the test. 22, what kind of triangle do we got? Why? So to solve, I would set them equal to each other. What are my other options for triangles? Not isosceles, but scalene, which means all the sides are different. And so if they give me quantities in a scalene triangle, I really can't do the problem unless they give me a perimeter or something. And what's my other one? Equilateral, right? There is a right triangle, but equilateral would be what we wanted. When we're talking about the sides, we would call it what if we're talking about the angles? Equal angular, right? Okay? We get there, just set them equal to each other and solve for y. Even though it says find the value of x. 24, 25, and 26. We should be good at this because this is what we just got done taking a quiz on, right? What's the median? It goes to the middle, but it has to come from where? Has to come from the vertex to the opposite midpoint. What about an altitude? Does it start at a vertex? Yes. An altitude has to start at the vertex, and then it does what? Goes to the opposite side, making a 90-degree angle. That's it. It does not split it in half. So when I draw my triangle, and this is where some of you are still struggling, here's my altitude, straight down there. That's it for an altitude. Okay? When it says to name it, though, then you would name it. If it's XO, there's my X, here's my O. There's XO. Okay? The difference between an altitude and a perpendicular bisector is what? A perpendicular bisector, I'm looking for the middle, and I'm drawing a perpendicular line. It does not have to come from the vertex. So again, that was something on the quiz, or the quiz that we had to draw the other day, and we had some confusions with that. Okay? Questions there? 27. What am I going to do in 27? Well, first off, I would actually draw this triangle real quickly. I would draw this triangle so I would know what I'm talking about. Meaning, I don't really care what it looks like, but I'm just trying to show myself. Here's X, Y, and Z. Okay? The only reason that I went, because the next part says list the sides in order from least to greatest. So again, the side opposite of that angle kind of goes together, right? We don't want to really say it's corresponding, they just kind of work together. They don't have the same measurement, but they go together. Okay? So how am I going to do this problem? First, I got to figure out my angles, right? They tell me that y is 42, so I need to know what are the answers to x and z. So I'm gonna take those quantities in my problem. 2x minus 5 plus 4x plus 5 plus my 42 and set it all equal to 180. I'm gonna find that x and then put it into each one of those to figure out my two other angles. And then the sides opposite of them would have the same characteristic. Okay? Do I need to finish? We're gonna do really good with this, huh? 28, 29, and 30, scratch out. We have not done that yet. That's what we'll come back and do. See, we should have another whole chapter before this. Fill in the blanks. Perpendicular lines form 4 right angles. Complementary angles have a sum of 90 degrees. The sum of the angles of a linear pair is 180 degrees. Another name for the angles that make up a linear pair are what kind of angles? Supplementary, perfect. Adjacent angles are next to each other. That one's kind of a trick question for some people. An obtuse triangle has one angle that is greater than 90 degrees. In a right triangle, the two angles that are not the right angle have measures of yeah, that one's kind of confusing, right? But I would say measures of 90 degrees together, yes. So some kind of combination to make 90 degrees. The three angles of a triangle add up to 180 degrees. If none of the sides of a triangle are congruent, the triangle is called a scalene triangle. So we made it basically through the whole thing. Should be a piece of cake, right? Today, or yours is when? Monday, right? So you got plenty of time to, I would guess, study.